Another relationship that can be helpful to recognize is how to factor a perfect square trinomial. So these are the properties as they're stated, but I just want to kind of show why this works. If I have a plus b times a plus b, which means the exact same binomial multiplied by itself. If I apply the distributive property twice or use the acronym FOIL, I multiply my first terms. A times A is A squared. A times my outside is A times B. My inside terms, B times A is another AB. And then B times B is plus B squared. These two are equal, so they combine to be 2AB. The same thing sort of happens here if I had A minus B times itself. If I multiply this out, I still get a positive A squared, and then I have minus AB times minus AB. And then negative B times negative B is positive B squared. It works out the same way, except that this is, instead of being plus 2AB, I get minus 2 times A times B, because I have two of those identical terms. So unlike the conjugates, when I multiply a perfect square binomial, right? I multiply a binomial times itself. Instead of getting equal but opposite middle terms, I have equal middle terms. And so they just double. I get two of them each time. So the hallmark of this was beautiful, is that if I can look at an expanded quadratic term here, ax squared plus 2ab plus b squared, and I can recognize that pattern, I can skip straight to this factorization based on the sign of my middle term, right? If this is minus, then I'm going to have subtraction here as well. Whereas if the middle term is added, I'm going to have addition in my factored term as well. All right, so the trick comes, how do you notice this? So if you don't notice this, so I have an expression like this, I have no GCF because 9, 12, and 4 don't have any factors in common among all three terms, and none of them have, I don't have an X in my last term, so this can't be factored with GCF. Rather than go through trial and error or using the AC rule, which both will work for this, by the way, if I happen to notice the pattern that 9x squared can be written as 3x squared, and that 4 can be written as 2 squared, then I can just check. If 12x is equal to 2 times my a times my b. In this case, a equals 3x and b equals 2. So I want to see, is it the case that this is 2 times 3x times 2? And yeah, 2 times 3 is 6x, 2 times 3x is 6x, times 2 is 12x. So yes, that means I have that relationship. So first I looked over here to see if I could see square factors. And they were, right? We had 3x squared and 2 squared. And then we checked to see if the middle term to check to see if the middle term was 2 times A times B. And it was. So then in that case, I can use the perfect square binomial formula. That tells me, since this was addition, I have A plus B squared is equal to A squared plus 2AB plus B squared. Since that's what I have, I can go ahead and write that this is equal to A, which was 3x, plus B, which was 2. And that's going to be squared. Notice that this was plus or addition. And I use plus here as well. So my final answer here is just my 3x plus 2 squared. And that's just really a lot more simple than it would be if we had wanted to use our AC rule or a trial and error method. So that's our final answer. So now we're going to look at some examples, and what you want to do is train yourself to notice square numbers. You really want to memorize your perfect squares up through 25 if you can. The more of them you know, the easier this becomes. I know that 4 is equal to 2 squared, and I know that 49 is equal to 7 squared, and I'm going to make a note that this is subtraction. And what I want to do is check to see if negative 28x is equal to 2ab. So what I'm going to do is say 2 times, 2x, sorry. So 2 times 2x times 7. That does in fact equal 28x, which means I can use my perfect square binomial formula. I'll take my A and my B and I'll use the same sign as the original problem. And that's going to give me my answer. So it's the first thing, 2x, minus the second factor, 7. And that's squared. And that's my final answer. So here, I notice that 36 is a square number. And I notice that 4 is a square number. That would tell me that A is 6y and B equals 2. I want to know, does 2ab equal my middle term? Two times 6 is 12, times y is 12y, times 2 is 24y. So yay, we have a perfect square. And I'm going to start here and I'm going to say that I have 6y plus 2 squared. This was plus, so this is plus. This was a plus b squared. And that's my final answer. I'm going to write it just each of these one more time just so I can box it so you can see it is the final form. All right. The last one here looks intimidating, but don't forget, the first thing you want to check, like when I look at this, the first thing I see is an 81. So I know that's a square number, and I look and I see my 25 is 5 squared. So I'm just going to try to write these as perfect squares. 81 is 9 squared. Remember that any even exponent is divisible by 2. So I'm going to make 9c squared. So 4 divided by 2 is 2. And that's what's going to be squared. Here, 25 is 5 squared. And I also have a d squared, so that's 5d to the power 2. And I want to check 2ab. So 2 times a times b would be 2 times 9c squared times 5d. 2 times 9, or actually 2 times 9 is 18, but I don't have 18 times 5 memorized. But if you think of 2 times 5 as 10, 10 times 9 is 90. So it's a little easier to do in my head. And then I have my c squared and my d. And that is my middle term. So this is going to give me my a plus b squared. So what is my a plus b? That is my a was 9c squared plus my b, which was 5d, and that's what's being squared. I make sure that since I have a c squared and I have a 9, this is 3 times c squared, but 5d is not a square term, so I don't need to try to break this down further, and that's our final answer. Now, I will also say it's only 2 terms and they don't have any factors in common, but also this is a sum, so it wouldn't have been a difference of squares even if we had even if 5d had been a perfect square, we wouldn't have been able to break it down using the difference of squares because it was addition, not subtraction. But it isn't, but when you want to train yourself to see square numbers, and I saw that 9 and that c squared, and I was like, that's 3c squared. Is that something? All right, it wasn't, but you want to get triggered by them. So that is actually the end of that topic. Thank you for your time.